All right, so now let's apply what we know. So let's go find the slope of the tangent line, which we know is the derivative. So the derivative of a to the stuff is a to the stuff times the derivative of stuff times ln of the a, always ln of the number. So if I want to find y prime at 0, I get 3, sine of 0 is 0, cosine of 0, ln of 3, going slow. So this gives me 1, this gives me 1, so it's the number ln of 3. So that's the slope of the tangent line. Do not use a calculator, leave it like that. So now if I want to find the y value, I'm going to put x equals 0 in. So I have 3, sine of 0 is 0, so I get 3 to the 0, which is 1. So I have the 0, 1, xy point, and slope of ln of 3, so that gives me y minus 1 equal to 0, I'm sorry, not 0, it gives me ln of 3 times x minus 0. So y equal ln of 3x plus 1. All right, let's look at this one here. I've got a position given by this. I'm going to take the time to rewrite it so I see what inside function I've got. So I'm going to take the derivative, which is the velocity. So s prime of t is v of t. So I'm going to carry the 4. I'm going to take the derivative, bring the 2 down. Cosine of t to the 1 power. Derivative of cosine is negative sine of t. So I get a negative 8 sine of t cosine of t as the velocity. So I'm setting that equal to 0. And I'm finding the times, the when. So when does that happen? It's giving me no indication, so I'm going to use all values of t. All values of t, since it doesn't give me any, let's erase that, there we go. Since it doesn't give me any restrictions, so when does sine of t equal 0? And when does cosine of t equal 0? So sine of t will equal 0 at t equal k pi, right? Talked about that, k equals 0, k equal 1. And when does cosine of t equal 0? So that would be pi over 2 plus k pi. So that would come up here or go down here. So these are all of the values of t when the velocity is 0. All right, so find the acceleration, which is the second derivative at this t value if this is the position. So one derivative is the velocity, so I'd get cosine of 3t times 3. So I'm going to take the moment to rewrite it and put that 3 out in the front. And then acceleration would be another derivative, so I'll carry this 3 along. Take the derivative, negative sine of 3t times 3. So this gives me negative 9 sine of 3t. So I'm being asked to find at pi over 2, so a of pi over 2. So give me negative 9 sine of 3 pi over 2. So I know that's negative 1, so I get an acceleration of 9. All right, so I need to find the x values where the tangent line is horizontal to this function. So that means I want to find out when the tangent line has slope 0. So let's find the derivative. Derivative of e to the stuff is e to the stuff times the derivative of stuff. And then you could think of it as times ln of e, which is 1. All right, so I'm trying to find out when this equals 0. So I have two quantities to equal 0. This never equals 0. So I get x is 1/2. So this is the 1x value where the tangent line is horizontal.